Hello everyone, welcome to my STM32 project. I am Mazen, and today I'll be walking you through my project using the Cube IDE and the STM32. The STM32 board is a very popular microcontroller, coming in just about every shape and size you can think of. But for today's video, I'll be using the STM32F1, specifically the STM32F103 RBT6 series. So my project in a nutshell was creating a smart plant system that can water my plants when I'm away. The idea behind this project came to me when I realized that my plants are not getting enough water. Sometimes I get busy with work, school, or I'm traveling. So I wanted to create a system that could take care of my plants even when I'm not around. Now this video will be cut to two parts. The first part will be using the STM32 and the Cube IDE to program our microcontroller. This part on its own is enough. The components that we will need here are the moisture sensor, the temperature sensor, 16 by 20 LCD screen or any LCD screen that you wish to use, a relay, a DC motor, a tube, a power bank, charging cable that you don't need, jumper wires, breadboard, and the software we'll be using is the Cube IDE. Now I said that was for the first part, simply because the first part deals with the STM32 and the Cube IDE in low-level coding, but the second part deals with the ESP32, and it could be a little project on its own. This is why I said it's a different part of the project. But the ESP and the STM, they work well together, and although you can use the ESP32 and the compiler Cube IDE, I will not be doing this today, simply because it makes the code more complicated and the logic more complicated, and it's very hard to get it in low-level coding. If you want this using the HAL library, we can do this, but that will be in a different video. The ESP32 is amazing, and I'll tell you why in a second. First of all, the idea behind it is that you can control anything you want using the internet. So as long as you're both on the same network, you can control it from your phone or your computer. And the purpose for today's project will be controlling the DC motor from my phone using Blink. And the components that you need for this part are the ESP32, jumper wires, DC motor, charging cable, power bank, and a breadboard. The software that we will be using is the Arduino IDE. So let's go through this step by step. For part 1, the sensors that I'm using are connected to the STM32. The idea is to collect its data and then display it on the LCD using the Cube IDE to program it. So I program my board to check for the moisture level, the temperature, as well as controlling the DC motor. Now my DC motor is connected to a power bank and a relay, and the relay is connected to the STM32. So the logic here was how can I make it work so that it pumps water every while for a specific amount of time. This system also takes into account the temperature and the moisture level, especially the moisture level. If the moisture level is below a certain percent, then that will trigger the relay so that it can turn on until it reaches a threshold of moisture. So let's say the moisture level is below 30%. What will the program do? Well, I program it so that it can turn on the relay, which in turn turns on the motor that's taking power from the power bank and therefore pumping the water. But for how long or how much? Well, that goes to the next part, where I programmed it to turn off after 60%. Well, but what if there's no water? Is the motor just going to turn on forever? That's where things get interesting. You see, if I programmed it that way, then the motor was just going to turn on, taking power from the relay or the power bank indefinitely, and it will shut off. It will burn. So I set it that it can work for maximum of 3 times in a span of 1 minute. With that being said, if we have the moisture level below 30%, then it will keep pumping water until it reaches 60%. It won't need the second time or third time. But if there's no water, then it can turn on for 10 seconds for 3 times in the span of 1 minute. And that's just for testing. We can change the span of time to 24 hours or a week or 2 weeks, depending on the plan that you want to use. Now let's build the schematics.
Okay, so for the schematics here, you can see it on GitHub. We have the button connected to A0, soil moisture connected to A1, the temperature sensor connected to A2, the relay control is connected to A3, and then we have the display, the SCL and the SDA connected to PB6 and PP7. When we go to the ESP32 schematics, it's pretty straightforward. We just connect the relay to the motor, which is connected to a cable, which is connected to the power bank. Same story with part 1, when we were connecting the motor to a relay and connected to a power bank. I'm using the exact same power bank, just different cables. So this cable is for the ESP32, and the other cable with the same thing is connected to the STM32. But for this one, we are connecting it to pin number 5 on the ESP. So yeah, that's the schematics.
And that's how it looks like. And finally, the coding part. Okay, so for the coding part, we will need to go to the GitHub We can download the code. Now we can open the file. We will see documentations for iPod 2. Now, when we go to the Cube IDE, we will say File, New STM32 project. It will take some time. So when it's done, we're just going to search for the STM32 F103 or BT6. We'll click on it. We'll say next. Let's name this GreenRoot. We go here, we say empty, and then we finish. We go to GreenRoot, double click on it. I'll go to properties, C or C++ general, pass and symbols, say include, and here I will add some files. Go to the file system and I will search for my chip headers. I will include that in the GitHub as well. I'll go to Census, device, STM32 F1, include, and then I would say OK. I'll do the same process again, file system, but this time I will go to chip headers, Census, include, and then I would say open and OK. I'll apply this. Now I'll go to the symbols, and these ones matter. These are very important. So I'm just going to say add, I'll type STM32 F103 x6.h, and I'll say OK. I will add another one, and notice that the case matters. 32 F103 x, and then capital B, and I would say OK, apply and close. Now we can go to the files that we have here for the iPod 2. We'll go to the include ones and just select all and move them to my include folder. I'll say OK. I'll click on source, do the same thing. And I will click OK. I'll override the main.c because it gave us a main.c, an empty main.c by default. So I'll override that. Same thing for syscalls, and same thing for sys.c. Now we can see that the files are here. I'll go to main.c and I explain everything in the code here. So I'm just going to explain or go over the relay very quickly. This one is an activation period for 24 hours. This one is 1 minute. It's not in milliseconds. The milliseconds function is not exactly, because 1 minute in milliseconds is 60,000, not 6,000. So this one here, define max activations, means that it activates 3 times if it's below a certain degree, and that means for how long. So here we have 3 times activation for the span of 1 minute. I can change this to 4, to 2, to 1, and I can change this to anything I want. So here I'm just gonna run the program to see if it's gonna build or not. Sometimes it just does that. Okay, build again, and I'm getting 0 errors and 0 warnings. Sometimes it messes things up or it doesn't go thoroughly through the code, so it gives you some errors, especially because we changed the syscalls and stuff like that. So just compile again, 0 errors and 0 warnings, and now I'll just click run. I'll say OK, and I can see that it compiles successfully. Okay, so if you're facing the same problem that I'm facing right now, like even though we're building and we're getting 0 errors and 0 warnings, we just get this. And on the LCD itself, it just displays Celsius, so just displaying C with no numbers. We can just fix this by going to GreenRoot, Properties, C or C++ build, and then Settings, and then Tool Settings. And then we can see here this and this. We can just enable both of them, apply and close. Now the error is gone. So when we build again, and then we run the program, it should be running and there should be no issues now. So now that we're done with the coding, we can test it. And that was part 1, the STM32 product. Now that we're done with this, we can move on to part 2, which is using the ESP32. And now we can go to the coding part using the Arduino IDE. So now we can go to the relay ESP32 file, download this file from here, and then we'll end up with this. You verify and then you upload the code, and you can get the IP address from your serial monitor if you're doing something with the internet, or if you want to show a message with over your local host. You can do it from here. After that, we can go to Blink. After you sign up, we can go to Developer Zone, create a new template. For me, I call it DTH11, but we're not dealing with DTH11 right now. I have some data streams, temperature, humidity for the DTH11, but right now we're just using the relay. I'm just going to go home, devices. You can create a new device from here. I called it relay. And you can edit the dashboard. You can add anything from here. The widgets, I added a switch, called it relay. Verify the settings to have a data stream to relay V5, because that's where it's connected to my ESP32. And pretty much that's it. Also, you have to verify it as not a virtual pin, but actually, I'll show you. If you add a switch here, you can go to settings, you can create a data stream, and you have to create it as a digital pin, not a virtual pin. And then you can say pin 5, but we use that, so it's not going to allow us to do that, and then you can just create it. I'm going to click cancel because it's already created. And now we have it here. So when I click on it, it should turn on the relay. I'll show you in a second. I should also mention that you can download the Blink application from your phone. So I'm just going to test it from here, and here you can see the motor. So I'll click turn on, turns on, and then off. I'll also do it from my phone. So it just turns off and on the motor. This is how we can do it. Well, that was the end of the video. Thank you guys for watching.